So in this lesson, we're going to solve equations that have multiple steps, not just one step, not just two steps, but several steps to them. So as you look at example 1, you've got a 2x and a 3x, and here are our left and right side of that equal sign. We have to be able to get the x terms all together on one side, which they are, but they're not one term. And so these are called like terms. Both terms have an x to the first power, and they look alike, they just have different coefficients. So you can look at a 2x as being 2x's, and then a 3x as being 3x's. So if we were to add on the same side 2x's and 3x's, we would have a total of 5x's. So all we have to do is add those coefficients. So I can replace 2x plus 3x, oops, not with a 3x, I can replace 2x plus 3x with a 5x. And don't forget your equals and bring down the 20. We didn't do anything on the right side. Now all you have left is a one-step equation like we've solved before. And to get the 5x to get the x by itself, we want to undo 5x, which is multiplication, and we want to divide both sides by 5. That way the 5's here cancel, and you're left with an x on the left. 20 divided by 5 is 4. Example 2. The only difference between example 1 and example 2 is your variables are on the right side. But as you can see, I've got 5p's and 3p's. These are called like terms. So we're going to collect these. They're both on the same side. So I'm just going to take 5p's and add 3 more p's to it. That's going to give me 8p's altogether. So I will replace 5p plus 3p with 8p. Nothing else changes. The 9 doesn't change. Don't forget the equals. And the minus 7, you're going to bring that down as well. And this leaves you with a simple two-step equation. We've got to get this 8p all by itself. It is on one side, but we need to get this by itself, and we need to get rid of a minus 7. So to get rid of this minus 7, the opposite is to add 7. So we're going to add 7 to both sides. The 7's cancel on the right. 9 plus 7 is 16 equals, and then bring down the 8p. Now you have a one-step equation. To solve for p, we want to undo 8p, which is multiplication, by dividing both sides by 8. The 8's cancel, and we get a p on the right. 16 divided by 8 is 2. Example 3 is different from examples 1 and 2 because this time, instead of our two variable terms being together on the same side, you have one variable term on the left and one variable term on the right. So I can't just take 8x plus 7x and say it's 15x. We've got to actually move the 7x over to the left or the 8x over to the right side. Anytime you cross this brick wall, in order to move something, you're going to have to add its opposite. So look at these two terms. We need to get them together on one side. I suggest that you always move the smaller term. So between 8x and 7x, 7x is your smaller term. So the opposite of 7x is a negative 7x. So we are going to subtract 7x from both sides. The 7x is on the right cancel, and on the left we have 8x minus 7x's gives you 1x, bring down the minus 5, equals, and bring down the minus 7. Now it's a brand new problem. We have this one-step equation where we've got to get the x by itself. We have all the x terms on the left side, but it's not by itself. So to get this by itself, we want to get rid of a minus 5. The opposite of minus 5 is adding 5. So we're going to add that to both sides. Cross out the 5's. We get an x equals a negative 7 and a positive 5. Subtract, keep the sign of the larger, you get a negative 2. Example 4, just like example 3, we have a variable term on both sides. We can't collect them because they're on different sides. But what we can do is either move the a to the right or the negative 5a to the left. So out of these two terms, we've got a positive 1a and a negative 5. The negative 5 is the smaller. We're not thinking absolute value like we do with integer roles. Negatives are always smaller than positives, so you would be better off moving the negative 5a to the left. So to move the negative 5a, the opposite would be to add a 5a. The a's cancel on the right. We end up with, this is really a 1a here. You don't see the coefficient, but it's really a 1. We're going to add 1a to 5a's. That gives us a total of 6a's on the left, plus the 3, equals a 9. Now we have a two-step equation. We have all our a terms on the left, but it's not by itself. We need to get this 6a all by itself. So we are going to do the opposite of a positive 3, which would be to subtract 3. So the 3's cancel. We are left with a 6a equals 9 minus 3 is 6. Focus on your a. To solve for a, we're going to undo 6a, which is multiplication, by dividing both sides by 6. So the 6's cancel, and I'm left with an a equals 6 divided by 6 is a positive 1. Example 5 and example 6 are the most difficult problems in these notes because they combine the skills that you just learned from example 1 and 2, which was collecting like terms on one side only, and the skills from examples 3 and 4, which was how to get variable terms that are on the left and the right side together on both sides. So as you look at these problems, not only do we have variables on both sides, but for instance on the left side here we have multiple variable terms that could be combined. So if variable terms on the same side, we're going to combine like terms by just adding their coefficients. So for instance in example 5, these are our like terms, so I'm going to underline them. I don't include the 2x because it's not on the same side. So a negative 3 and a positive 4 gives us a positive 1x equals, and then we're going to bring down the 7 plus 2x. I can't do anything with 7 plus 2x because they're not like terms. The 7 doesn't have an x attached to it, so I couldn't do anything with the right side. So at this point I have an x term on the left and an x term on the right. I want to collect them. According to how I taught you before, we want to move the smaller term. So this problem's a little difficult. I mean, you could move the 2x to the left by subtracting 2x. The problem with that is you end up with a negative coefficient, and oftentimes you drop your negatives and get wrong signs, and so your answer turns out to be wrong. In this case, I'm going to have you subtract x from both sides. And the reason why we're choosing to subtract x is because the x term is smaller than the 2x. So if I subtract x from the left, I have to subtract it from the right. The x's cancel. And here's the negative about moving the x. If everything cancels on this side, nothing is left on that side. And if nothing is left on that side, it has a value of 0. You have to put that value of 0 in there because it's a placeholder. It tells the reader that the left side has no value or a value of 0. The right side, however, still has a 7. So we didn't do anything with that. We're going to bring that down. But then you have to actually collect these. So a 2x minus an x is a positive 1x. The other issue with solving this equation this way is that oftentimes students will drop the equal sign and then they'll just say x equals 7. But that's not true in this case. We've got to get the x by itself, and we have to get rid of a positive 7. To get rid of a positive 7, you have to subtract 7 from both sides. The 7's on the right cancel. 0 minus 7 is a negative 7 equals x. So the actual answer is negative 7. Example 6. So in example 6, we have the same situation. We have variables on both sides. But on this side, I don't have anything to simplify. So I can't do anything with the 6x, so I'm just going to bring it down and put in my equal sign. But I can do something with a negative 5x and the negative 3x. You've got to view them as if they're negatives and not as if these are subtraction signs. So if I add a negative 5 and add a negative 3, they're the same sign, so we're going to add and keep the sign. That gives me well, first of all, I'm going to bring the 28 down because I'm not doing anything with it. But the negative 5x plus a negative 3x, add and keep the sign, gives you a negative 8x. So now I've cleaned up this side, if you will, and made it prettier. However, I still have a variable term on both sides, so I have to get the variables on either the left side or the right side. Out of 6x and negative 8x, the negative 8x is smaller because it's negative. Negatives are always smaller than positives. So the opposite of minus 8x is a positive 8x. So I'm going to add 8x to both sides. 6x plus 8x is 14x equals, and then bring down the 28. Now you have just a one-step equation. We're going to solve for x by undoing 14x, which is multiplication, by dividing both sides by 14. So we end up with x equaling 28 divided by 14 is 2. So now go and try these 6 board examples. You can find them on my website under worksheets, and it'll say multi-step board problems.